Okay, now look at this question. Okay, calculate the gravitational potential energy at 160 kilometer from the Earth's surface. Oh, on the surface for a 45 kilogram object. Okay, given the mass of Earth and also radius of Earth. Look at this question again. It say this one from Earth's surface. Compared to before, this question, this is from the center. So this is the R, not the H. Okay, but this time it is from where? From the surface. So I want to ask you, is this the R? Is this the H or the R? So we all know the answer is not the R. It is the H. It is the H, because from the surface, this is or we can say this is the height. This is the height H. This is the height H, or we call it altitude. Yeah. So this is remember this one, you have square some more. No, you have a kilometer some more. So you have to change it to SI unit. Okay. So this is the H, not the R, because from the surface. Okay, and you also give you want to find the potential energy. Yeah, potential energy. So this one is U. Okay, you need to find U, and then 45 kilogram object. This is the test mass. This is the test mass. Okay. And then mass of Earth. This is the mass of Earth. Okay, this is the point mass, the one who the provider of gravitational field. This is the provider of field, and the radius of Earth is given. Okay. So let's find out the formula. Potential energy is negative gmm over r. The r is, you must take the not just the altitude, you must plus with the radius of Earth. Remember? Okay. Okay, remember that. So let's do this question. So U is equal to negative gmm, gmm over what? Over R. So the R here, remember the R here is not just the altitude, not just the altitude, not just the H. You must take radius of Earth plus H. Okay, R is radius of Earth plus H. Okay, so we already got all the information. Let's calculate the answer. Yeah, so G is 6.67 exponent negative 11, and mass of Earth is 6 exponent 24. 6 exponent 24, mass of Earth. 6 exponent 24, and then mass of the moon. No, not mass of moon. The 45 kilogram test mass. That's 45 kilogram. Okay, 45 kilogram object. Okay, divided by what? Divided by the radius of Earth. Radius of Earth is 6.4 exponent 6. 6.4 exponent 6. Okay, and the radius of Earth, that's the radius of Earth, and then plus the height. What's the height? 160 kilometer. So you need to convert that one into exponent 3. Convert to SI unit. Exponent 3. Okay, so remember, no square. So for scalar quantity, if you look at this scalar quantity, so what is this? For the scalar quantity, the R doesn't have any square. Let's calculate the answer. Okay, so I got the answer already. It is negative. Remember the negative sign. Don't forget the negative sign for potential energy. You owe energy to the Earth. So this is 2.75. 2.75. I got 2.75 exponent Let's calculate. Let's count it. 369. 369. So in 9, joule. Potential energy is joule. Okay, so that's the answer. Is that correct? The answer? The answer is, yeah, correct. Okay, 2.75, negative 2.74, almost the same, yeah. Exponent 9 joule. Okay, exponent 9 joule. Remember, this negative is not about direction. This negative is you owe energy. You owe energy. It's not about direction. Some people say, oh, negative sign means direction. No, it's not about direction. It's not about direction, because scalar quantity has the scalar quantity has no direction. Scalar quantity has no direction. So this negative sign is not about direction. This negative sign is not about direction. It's about you owe energy to the earth. You owe energy to the earth. Okay, owe potential energy to the earth. You want to escape from the earth, you need to pay this amount of potential energy in the form of kinetic energy, escape velocity. Then only you can escape. Okay, so it's not about direction. It's about you owe energy. Okay, it's not about direction. Okay, so that's all for these questions. Okay, hope you understand. Okay, let's move on.